This is Student Workbook 1.K Free Fall. It's very similar to the last one, except in this case we're going to continue past the initial setup. So again, the rocket is going to fire and cause us to accelerate at 5 meters per second squared, they say, for the first 10 seconds. And then the engine's going to shut off and we're going to fall back. So this time, notice the difference is they say map it out for the first 20 seconds. So if I sort of mark on here, they didn't give me any axes, but I'm going to go 2, 4, 6, 8, 10. And then I'm going to be right in the middle here at the 5 for the first 10 seconds here. So I'll make a little mark there. Whoops, make a little mark there. And then for the first 10 seconds, we've got an acceleration of 5 meters per second squared, and that is constant. After that, we drop down, and if I go here, this is -2, -4, -6, -8, -10. So we'll be down here from 10 seconds on to the end, and so we instantly jump from our acceleration upwards of 5 meters per second squared down to free fall of -10 meters per second squared there. So now let's get to the velocity versus time graph here. So in this case, again, they haven't given us any axes. Ones that work well are to go 10, 20, 30, 40, 50. Because I know from my previous page that that's what I'm going to get up to before I start to slow down. And then again down here, -10, -20, -30, -40, -50. So we can use our one from the previous one to know that after 10 seconds that we're going to get up to 50 meters per second. And I'm going to draw that line there. So this is the same. We start out at 0 meters per second. We get up to 50 meters per second like that. And then we're going to start to lose speed. So after 1 second, right here at the 11, we're going to have already lost, because we're in free fall, 10 meters per second of our speed because of gravity. So it's going to pull us down like that. And so I can use these two to make a line to finish on the rest of the way there. Like that. So that is what our second graph looks like. Moving on to the back side here, they say that we've got, using the kinematics equation, y equals y0 plus vy0 t plus 1/2 ayt squared. This is the third equation. Just they've changed the x's to y's because we're going vertical now. A classmate writes out the following solution to find the time when the rocket lands back on Earth. Explain in one sentence, using terms such as acceleration, velocity, position, constant, changing, and zero, why this solution doesn't work out. So the student said, like, well, my final position will be on the ground, 0. I started on the ground, so put that in as 0. I started from rest, so put initial velocity in at 0. And then find the time. By the way, if you try to solve this, all these are zeros, the time's going to be 0. So what's wrong with this problem? Well, anytime you have two distinct stages, so like the rocket firing up and gravity pulling you down, you need two distinct sets of equations there. So you can't just do that. And so the best way to do it is you're assuming there's a constant acceleration of 5 meters per second squared the whole time, and there's not. That's why it won't work. It's only 5 meters per second for the first 10 seconds, and then that changes. So next part says, from your velocity versus time graph in part B, determine the time when the rocket reaches the maximum height, and write it here. Well, notice this whole time up until here at 15 seconds, we were going up. Here we were just increasing our speed up. Some people start to think here we're coming down, but that's not true. We're just losing our upward speed. It's only there at 15 seconds that we first got a negative velocity and start to come down. So right there at 15 seconds is when we get a negative velocity and come down. So time for the rocket to reach its maximum height is, whoops, why am I writing a negative there, is 15 seconds there. And I already explained how I arrived at my answer. And then the last bit I forgot to print off down here, but it says, make a claim about the rocket's maximum height, and then they want you to actually find it. And so there's a couple different ways you could do it. You could do it with an equation, or you could look at this graph right here, and you can realize that all the way up into here I was going up. So this is my maximum height occurs at 15 seconds, and then we start to go down. So this entire area here can show me my displacement. So I got two areas I'm going to find. This one right here, I'm going to find that triangle. Remember, 1/2 base times height. Well, you could do this in 2 steps or in 1 step there. So this is 10 times 50, so that would be 500. Half of that is 250 meters. And then on this side right here, our base is from 10 to 15, so it's 5. Our height is 50 again, so 5 times 50 is 250. Half of that is 125 meters. And so this section's 250, this section's 125 meters. So all together, you get 375 meters is the maximum displacement there, and that's the maximum height.